Hello and welcome to Data Science Supervised Machine Learning in Python. In recent years, we've seen a resurgence in AI, or artificial intelligence, and machine learning. Machine learning has led to some amazing results, like being able to analyze medical images and predict diseases on par with human experts. Google's AlphaGo program was able to beat a world champion in the strategy game Go using deep reinforcement learning. Machine learning is even being used to program self-driving cars, which is going to change the automotive industry forever. Imagine a world with drastically reduced car accidents simply by removing the element of human error. Google famously announced that they are now machine learning first, meaning that machine learning is going to get a lot more attention now, and this is going to drive innovation in the coming years. Machine learning is used in many industries, like finance, online advertising, medicine, and robotics. It is a widely applicable tool that will benefit you no matter what industry you're in, and it will also open up a ton of career opportunities once you get good. Machine learning also raises some philosophical questions. Are we building a machine that can think? What does it mean to be conscious? Will computers one day take over the world? In this course, we are first going to discuss the k-nearest neighbor algorithm. It's extremely simple and intuitive, and it's a great first classification algorithm to learn. After we discuss the concepts and implement it in code, we'll look at some ways in which KNN can fail. It's important to know both the advantages and disadvantages of each algorithm we look at. Next, we'll look at the naive Bayes classifier and the general Bayes classifier. This is a very interesting algorithm to look at because it is grounded in probability. We'll see how we can transform the Bayes classifier into a linear and quadratic classifier to speed up our calculations. Next, we'll look at the famous decision tree algorithm. This is the most complex of the algorithms we'll study, and most courses you'll look at won't implement them. We will, since I believe implementation is good practice and prevents you from thinking you know something when you really don't. The last algorithm we'll look at is the perceptron algorithm. Perceptrons are the ancestor of neural networks in deep learning, so they are important to study in the context of machine learning. Once we've studied these algorithms, we'll move to more practical machine learning topics: hyperparameters, cross-validation, feature extraction, feature selection, and multi-class classification. We'll do a comparison with deep learning so you understand the pros and cons of each approach. We'll discuss the scikit-learn library, because even though implementing your own algorithms is fun and educational, you should use optimized and well-tested code in your actual work. We'll cap things off with a very practical real-world example by writing a web service that runs a machine learning model and makes predictions. This is something that real companies do and make money from. This is a course about how to write these algorithms yourself. We all know that in the end, you'll end up using a robust and well-maintained library like scikit-learn. Even I use it. But there's a big difference between a data scientist who only knows the main ideas about why these algorithms work and can regurgitate some facts about each of them, versus a data scientist who has put in the work to implement these algorithms by themselves and understands the ins and outs of the theory and the code. The data scientist who understands the ins and outs and the advantages and disadvantages of each method is the data scientist who is more likely to get hired and is more likely to be able to choose the right tool for any given problem.